Hello everyone, I am Andela Indira from Department of Electronic Science, Sangamne College. So, this is a lecture series for the first video for the basics of electronics for the minor students. This is the syllabus for the minor students and we are going to start with the first lecture of the basic component, that is nothing but your resistor. So, what is a resistor? Resistor is basically a two terminal electronic device which offers the opposition to the flow of electrons. So, the resistor looks like this and the circuit symbol is being displayed. So, how the actual resistor works? It works on the principle of Ohm's law, which since we are studying this Ohm's law since the schooling, like V is equal to I into R, where the voltage is directly proportional to the current flowing through the circuit and R is nothing but the proportionality constant. And we are going to study the resistor in two topologies, that is in first the series topology and the second is the parallel. When the resistors are connected in series, the only single terminal is common, whereas in parallel both the terminals are connected with each other. This you can see there are 4 resistors R1, R2, R3 and R4 which are connected in series, and you can see a single connection or the single terminal is common in both the resistors, in every resistor, and a single voltage source is being applied in the circuit where you can see a single path is being represented by the arrows. So, here the current which will be flowing through the circuit would be the same in all the resistors, whereas the voltage drops would be different, which we are going to discuss in the further slides. Here you can see that if the resistors are connected in series, the first is being displayed as all the components conduct the same current. As I said, the resistors, if they are connected in series, then the current which is flowing through the circuit would be the same throughout, and the resistances would be added for the equivalent resistance. That is, in the previous slide, if you see here, the 4 resistors are being connected in series. So, the equivalent resistance of this circuit would be R1 plus R2 plus R3 plus R4. That has been mentioned here. Now, if you see the voltage split, that is, if these resistors are connected in series, so therefore, the voltage which is being connected here will have a drops across each resistor. That is, the voltage across R1 would be VR1, VR2, VR3 and VR4. By using a KVL, we can prove this, that as the voltage across all these resistors, the sum of the voltages would be equal to 0. When the series action has been performed, you can see the 3 resistors as an example. The first resistor is 3K, second 10K and the third is 5K. They are connected in series, hence the equivalent resistance which we get is 18K. And if you see, there is a voltage which has been connected as 9 volt is connected across a 18 kilo ohm resistor, then the current which has been flowing through the series circuit would be 500 microamperes. And if you see the voltage, if you calculate the voltage drop across each resistor, then you will get as VR1, that is nothing but the current into the resistance will give you 1.5 volt as VR1, VR2 as 5 volt, VR3 as 2.5 volt, and when you add up the 3 voltage drops, you will get the approximately which would be 9 volt, which proves the KVL. Now, the second topology which has been discussed is the parallel circuit. Here you can see the resistors, the 3 resistors, the 2 terminals of resistor all are connected with each other. The first terminal of R1, second terminal of R2 and the third terminal, that is the third resistor of terminal 1, all are connected with each other, and similarly the other terminals are also connected with each other. So therefore, they are said to be in parallel. And this parallel circuit, you will see the voltage would be constant across all the components, that is the resistor R1 would be having the same voltage which was being applied across the source, and the resistor R2 will also have the same voltage and R3 would also have the same voltage. So, hence it is said that the voltage is exactly the same for all the parallel components connected in the circuit, that is in the parallel topology. Whereas, the interesting part is nothing but the current splits. So, the node, this is nothing a point which is said to be a node where the current is being diverted or that is splitted into the paths. So, therefore, the current which is being generated from the source would go towards R1 and towards R2. So, therefore, this is called as a node. So, hence it is said that the total circuit current is the sum of the individual branch currents, that is, if you see there are 3 outgoings, that is nothing but a node consisting of 3 outputs, then the entering current is nothing but, if you consider I1, you will be having the sum of I1 plus I2 plus I3 is equal to the I, which is I total is I1 plus I2 plus so on In if n number of current splits are been mentioned. Similarly, if you see the resistances across in parallel, that is the reciprocal of the sum is nothing but the resistance, that is if the 3 resistors are connected in this, then the RT would be calculated as 1 upon RT is equal to 1 upon R1 plus 1 upon R2 plus 1 upon R3. So, that is nothing but the resistance drop in parallel circuits. So, the same we can see using an example that R1 if it is considered as 10 K, R2 as 2 K, R3 as 1 K, then you can see that the constant, that is the current are being calculated, and how to calculate this current is nothing but IR1 would be the current which is being flowing through R1, that is can be calculated using Ohm's law. I is equal to V upon R. So, that by that we will get 0.9 milliamperes as the current which is flowing through R1, and R2 is nothing but the voltage is the same. So, therefore, you can directly consider that 9 volt upon 2 K would give you 4.5, and R3 as the current which is nothing but 9 milliamperes is being the current which is flowing through the R3. And the interesting part you can see here is nothing but the current which would be generated from this source would be the sum of all these currents, that is 0.9 plus 4.5 plus 9 amperes will give you the total current which would be generated across this source. And the interesting part is the greater the resistance, the smaller is the current, and the smaller the resistance and the larger would be the current which will be flowing through the circuit. And you can see the Kirchhoff's current law which is being obeyed here, that is the total current which is coming towards the node is nothing but the sum of the currents which is 14.4 milliamperes. So, we have a comparative chart here where you can see the series topology versus the parallel topology. The resistors connected in series are only single terminal is common, whereas in parallel the resistors are connected with each other, that is every terminal is connected with each other by the second resistor. And if you see the series topology, the voltage rule which says that the voltages across each resistor would be the sum, and here the voltage law says that in parallel if across each resistor would be the same, the voltages across each resistor would be the same. And if you see the current rule in the series resistors, the current is the same throughout the circuit, whereas here in the parallel the current would get splits because there would be nodes present in the circuit. And hence the last is nothing but the resistance rule which says that the resistors, if they are connected in series, the resistance, equivalent resistance is the sum of the resistors, that is RT is equal to R1 plus R2 plus R3 would be in series, whereas in parallel you can see the inversely proportionality, that is 1 upon RT is equal to 1 upon R1 plus 1 upon R2 plus so on till 1 upon Rn. That is nothing but if you two resistors are connected in parallel, then the equivalent resistance RT is equal to R1 R2 upon R1 plus R2. So, Here you can see we can focus on the family tree of resistors, where the resistors are basically of two types, that is a linear and non-linear. So, linear is nothing but the value changes predictably with applied voltage or the temperature, that is the standard voltage drop can be observed in the linear, and where the linears are divided again classified into two, that is a fixed value and variable value. Whereas, in non-linear the value will be changing, that is not disproportional with each other, that is the current flowing is nothing but disproportionally with voltage or the temperature, that is the Ohm's law is not followed in non-linear and Ohm's law is followed in linear. So, if you see the example of non-linear, the best examples are the thermistor, that is the temperature dependent resistors, and LDRs, which are the light dependent resistors. And if you see here, the fixed type of resistors look like this, and these are the wire wound or the carbon composition resistors can be considered as a fixed type of resistors, and these are the variable resistors where you can consider the potentiometer or rheostats, which you use in are practical, and they consist of three terminals. The extreme terminals are nothing but the fixed value, and the middle terminal is nothing but a variable value, where you can measure the value of resistance across the two terminals. Then you can see the reading, and it is used for the tuning purposes. And non-linear resistors like the temperature and LDRs, which act as the sensors nowadays. And the most important point is how to calculate the resistance value if it is displayed the color code on the resistor. You can see here that the resistor is consisting of bands. The resistor is consisting of bands, and here the first band is nothing but here it is yellow. So, yellow is having a 4. So, this would be representing a 4 value of 4. The second band is your purple, that is the violet, and here you will have a value of 7 violet, and the third band is your multiplier. So, the third band is having a value of 2. So, here this would be a multiplier, and the fourth band will represent your tolerance, which says that the manufacturing will have a plus or minus value which would be differentiating. So, here you are having a golden color. So, the golden color is having a plus or minus 5%. So, this is your plus or minus 5%. The final value of this resistor having these bands is nothing but 47 is the value, into the multiplier is your 2 10⁻². Ohm plus or minus 5%, that is nothing but you can write the same as 4700 ohm plus or minus 5%, or it is same written as 4.7 into 10⁻³ ohm plus or minus 5%, that is nothing but 4.7 kilo ohm is the value of this resistor with 5% of tolerance. So, this is all about basics of resistors. Keep watching my videos. We will be catching you in the next lecture with the capacitors. Thank you so much.